Alright, lesson 4-7. This is called arithmetic sequences. Okay, we have two objectives here. The first one is definitely much easier. That's just to identify and extend patterns and sequences. I think you guys are going to find that part very, very easy. The second part, to represent arithmetic sequences using function notation, is definitely much harder. And in order to keep this video short, I kind of only have one or two examples. So don't get frustrated if you don't understand. We'll definitely do a whole bunch of these in class, but it's just a matter of really, you're going to have to memorize these formulas, and this is one of those great opportunities where watch it now, go over this stuff in class, practice it a lot in class, and then you can watch this video as many times as you need to until you kind of have a whole grasp of this stuff, because it's definitely pretty difficult at the end. Okay, starting easy with some vocabulary. So we have a sequence. It's just an ordered list of numbers that often form a pattern. So you've done these before, like 2, 4, 6, 8, ... That's a sequence. Okay, that's just a sequence of the even numbers. Terms of a sequence, that would be each number in that ordered list is called a term. So they're all going to have a number. So this is going to be term 1. Okay, this is term 1. This is term 2. Okay, this is term 3, term 4. So a sequence, just an ordered list of numbers. A term of a sequence is just each number in that term. The only reason this is really important is because the first term, when we get into the part at the end, the first term is going to be very important, but that's just term number 1. That's the very first number. Okay, this is probably pretty easy. Problem 1 says, describe a pattern in each sequence. What are the next two terms of each sequence? So the reason these are spaced out so much is so that the easiest way to do this is to figure out how you're going from 5 to 8. That was plus 3. Okay, from 8 to 11, that was plus 3. And from 11 to 14, that was plus 3. So describe a pattern. That would be add 3. You could say add 3, you could say add 3 to find the next number, but the pattern would be add 3. So what are the next two terms of each sequence? Let's see, if we add 3 again, 14, 15, 16, 17. If we add 3 again, would be 20. Okay, that pretty easy, I think, for you guys. Okay, part B, to go from 2.5 to 5, we multiplied by 2. To go from 5 to 10, we multiplied by 2. And from 10 to 20, we multiplied by 2. So the pattern would be multiply by 2. Okay, to find the next two terms, we want to multiply by 2 and we get 40. Multiply that by 2 and we get 80. That part, pretty easy, right? Okay, a little bit more vocabulary. Those things that we just did, those were both called arithmetic sequences because the differences between the consecutive terms is constant. Okay, if you're adding on the same number each time, that's constant. Okay, so either adding or subtracting. So this difference, whether you're adding 5, subtracting 5, that's called the common difference. Okay, and that makes sense because that's what you're going up or down by. It's a common amount. Okay, so right here we have to tell whether the sequence is arithmetic. And remember, that's if it goes up by the same up or down by the same amount each time. If it is, we have to state what the common difference is. So let's see, from 3 to 8, first thing you got to do is decide if you're going up or down. So we're obviously going up, so it's plus, and what we added was 5. And then did we add 5 again? Yep, and then we added 5 again. So tell whether the sequence is arithmetic. So yes, it's arithmetic. And the common difference, I usually just abbreviate and put CD. The common difference would be 5. Okay, and let's try the next one, 6, 9, 13, 17. So from 6 to 9 would be plus 3. From 9 to 13 would be plus 4. And from 13 to 17 would be plus 4. So because we don't have a common number here, this one would be no. No, it's not arithmetic because we're not adding on the same number each time. And if it's not an arithmetic sequence, then it doesn't have a common difference. Okay, now this is the tough part. I told you the beginning was easy, this gets kind of tough. So all a sequence is a function. Okay, and we've learned about function. Think about function notation. Remember, function notation is a function of x whose domain is the natural numbers. So if you think of domain, x values, y values. Natural numbers would be 1, 2, 3, 4, 5. So this is saying term 1, term 2, term 3. Okay, and then you're going to do some kind of function, and you're going to get out your y values. Okay, so let's see. A sequence is a function whose domain is the natural numbers and whose terms are the outputs. Wait a minute. Okay, we got to cut this part out. And it says, and whose. Cut this part out right here. That was like repeated in there twice. Okay, so a sequence is a function whose domain is the natural numbers. That would just be 1, 2, 3, 4, 5. And whose outputs are the terms of the sequence. So just like we had before, we had a sequence. Those are going to be right here. Okay, but instead of writing the numbers just like 2, 4, 6, 8, we're going to have some kind of formula of how we're getting those numbers. Okay, so we're plugging something in, and 2 is coming out. We're plugging something in, and 4 is coming out. That's why it's a function. Okay, a recursive formula, and this is something that you really got to try and memorize, is a function rule that relates each term of the sequence after the first. Okay, that's what recursive means. Recursive means that you need the one before it. So it relates each term of a sequence after the first to the ones before it. Okay, so let me show you what a recursive formula looks like. Okay, so it says consider the sequence 7, 11, 15, 19. The first thing we want to do is figure out if it's arithmetic. So is it going up by the same amount each time? So that's a plus 4, that's a plus 4, that's a plus 4. Okay, so it's an arithmetic sequence. Now we're going to write a formula for it. Okay, so it says, let n equal the number term in the sequence. All that is that this is term number 1, this is term number 2, this is term number 3, and this is term number 4. Okay, but you need a variable if you're going to have a function. So then we have a of n. A of n is the value of the nth term in the sequence. So if we want the value of the first term, that would be 7. Okay, so right here, value of term 1, which we're going to represent as A1, that's going to equal 7. Value of term 2. Now we know from up here that the value of term 2 is 11. But instead of just writing 11, because we're trying to write a recursive formula, the value of A2 is we're going to take A1, we're going to take the term before it, and we're going to add on 4, which is our common difference. So the value of A1 was 7. 7 plus 4 is 11. Okay? The value of term 3. We know it's 15, but how we want to write it is A3 would be the value of the term before it, A2, which was 11. 11 plus 4 was 15. So recursive means you need to know the number before in order to get the next number. So to get the value of term 4, A4, we need to know A3, which was 15, and we add on 4 and we get 19. So the value of the term n, which represents anything, like if we want the 20th or the 1000th, it would be an represents n minus 1. N minus 1 means if we're on the 4th term, we need the 3rd term because it was 1 before it. So if we need the nth term, we need the n minus 1 term, which is the term before it, and then we add on 4 because that's our common difference. Okay, so when you write this, if it says write a recursive formula, here's your recursive formula. An equals a, then the n minus 1 plus 4. but you have to state what the first term is, because you can't do a recursive formula if you don't know what the first term is. So a lot of people forget to write this part right here, but you have to write what the first term is before you can do a recursive formula. Okay, so I know that's kind of a lot, but just try and remember recursive means you need the number before it. And when you need the number before it, that's why you have that an minus 1. And then this right here, that plus 4, that's just the common difference, which you know you're going to add on each time. And remember, you have to state what the first term is. Okay, so it says write a recursive formula for the arithmetic sequence below. What's the value of the 8th term? So let's see, what are we going up by each time? So we got 70, 77, 84, 91. Plus 7, plus 7. Okay, let's start by writing A1. That's the first term. A1 is 70. Okay, in order to find A2, we need to take A1 and add on the common difference, which was 7. Okay, and we know that equals 77. In order to find A3, so that's why it was saying that this is just a function of the natural numbers. 1, 2, 3, 4, on and on forever. So to find A3, we need to take the term before that, which was A2, and we need to add on 7. Well, A2 was 77. So 77 plus 7 would be 84. Okay, you don't have to write all this out, but sometimes by writing it out a couple times helps people realize. So if I need an, all I need to do is take a, the n minus 1 term, which was the term right before it, and I need to add on 7. But you have to say if a1 equals 70. Okay, you have to say what that first term was. So there's your recursive formula, and the first term is 1. Now, it says what's the value of the 8th term. So we know the value of, we just need to continue the pattern. So let's find A4, which is going to be A3, which is 84 plus 7. 84 plus 7 is 91. Okay, to find A5, we're going to take A4, which is 91, plus 7, which is 98. A6 is going to be A5, which is 98, plus 7, which is 105. A7 is going to be A6, which is 105, plus 7, which is 112. And A8, which is the value of the 8th term, is going to be 112 plus 7, which is going to be 119. Alright, that was an awful lot of work just to find the 8th term. So that's one of the drawbacks of a recursive formula, is you have to know the number before it to find the next one. What if they wanted you to find the 100th term? Okay, if you think about, I rewrote this out, okay? There's a different formula. It's called an explicit formula. I'm going to show you on the next one, but it kind of gets confusing. But if you think about it, if you want the 8th term, okay, what we did was we started with 70. Then we had this common difference, okay? Each time it was going up by 7. Now, how many times did we go up by 7? Well, the first term is where we started. And then you think, if I just put blank spaces, so let's see, this is term 1, this is 2, this is 3, 4, and then this would be 5, 6, 7, 8. Each time we were adding 7. So how many times did we add 7? 1, to get to there, 2, 3, 4, 5, 6, 7. Okay, so we added on 7 times, but 7 is 1 less than 8, right? So we're going to take that common difference of 7, and we're going to multiply it by 7, because we really added 7 on 7 times. So it's really 70 plus 7 times 7 is 49, which is 119. Oh boy. Hold on. We messed something up on the... Okay, no we didn't. I was confused. We got 119. So, if you see what we were doing here, you were starting with the original number. And then the common difference, this right here was the common difference. Then how many times did we need to multiply that was one less than whatever term we were trying to get. So if we're trying to get, let's say, the 20th term, we would have started with 70, and then we would have taken the common difference, which was 7, and we would have multiplied it by 19, because we would have moved that up 19 times. And that's how you can very quickly find the 20th term. So this right here, this is an explicit formula. Okay, so here's the vocabulary for what I just explained. An explicit formula is a function rule that relates each term of a sequence to the term number. So if you want the 5th term, then you can just find the 5th term. You don't need to use the one before it. So here's the formula, and if you can memorize this, it's going to make it so much easier. So a to the n. Okay, whatever term you want, you start with a to the 1, just like we were doing, and you're going to multiply the common difference by 1 less than that number, just like we did when we wanted the 20th term. We started with the first term, which was 70, and if we wanted the 20th term, we took 19 times the common difference, which was 7, and that's how we get the 20th term. Okay, so obviously, if they're asking you for a term that's, I would say higher than 5, it's probably a lot easier to use the explicit formula than a recursive formula, because again, in a recursive, you have to know the number before it. You didn't really need to know the 19th term to figure out the 20th term here. So what's tough is what they're going to ask you in the next part is to switch back and forth between an explicit formula and a recursive formula and vice versa, which is why the sooner you can memorize these formulas, the more it's going to help you with switching back and forth, or at least understand them, maybe not so much memorize them. Okay, so problem 5. We have an arithmetic sequence is represented by this is a recursive formula. an equals an minus 1 plus 12. If the first term of the sequence is 19, write an explicit formula. So you have to realize, what's this 12? The 12 is representing the common difference, because you're taking the term before it and you're adding on 12. So that's one thing you have to identify. That's the common difference. In the first term, so A1 was 19. Okay, to write your explicit formula, explicit or recursive, you always start with A1. But in an explicit formula, you have to state what the first term is. So you have to state A1 plus, then you're going to take the n minus 1 term times d, which represents the common difference. Okay, that's just the generic formula for any explicit formula. So for this formula, we want to make it an. The first term is 19 plus, and then we always have n minus 1 because you're going to be multiplying by as many times as you need except for the first. So, and then the common difference is 12. Okay, so the explicit formula for this situation right here, this sequence, is an equals 19 plus n minus 1 times 12. Okay, and problem 6 is the opposite. Okay, an arithmetic sequence is represented by the explicit formula, and it gives you the explicit formula. What's the recursive formula? Okay, so you have to be able to recognize that if this is an explicit formula, that 32 right there, that's A1. Okay, now, there's two numbers here. How are you going to know which one's A1 and which one's the common difference? So I have a 32 and I have a 22. But think, the common difference is what you're going up by each amount of time. So that's what you need to multiply by. So 32 is your first term. Your common difference is 22. Okay, so the recursive formula always has this pattern. An equals A the n minus 1 term plus the common difference. Okay, so let's apply it to this situation here. We have an equals still an minus 1. Anytime you have a recursive formula, you're always going to have this piece right here, because you always need to use the piece before it, and then you're going to add on the common difference. And you have to say where, remember, if you're doing recursive, you have to say where a1 equals 32. So the major differences between the explicit formula is going to use multiplication. That's how you're going to come up with your number, skipping a lot of steps and go a lot faster. A recursive formula is going to use addition, because you're just going to take the number before it and continue to add on. Okay, now I know we only did a few of those, and it's going to take a while before you can work back and forth between them, but if you can have the formulas memorized by tomorrow, it's going to help so much. So try the lesson check on page 278. Okay, it has you first, real easy, just, describe the pattern, tell if it's arithmetic or not, and then try and work with some of the recursive and explicit formulas. Okay, and we'll start with that tomorrow.